The purpose of this demo is to show how a horizontal pod autoscaler can be used to increase the number of ACE pods as load increases on the service that is deployed. What we'll be using is an OpenShift cluster with 3 master nodes and 3 worker nodes. We'll deploy a horizontal pod autoscaler into the OpenShift system, and that will be looking for a specific ACE application called Scale App. We'll also have some form of client to the REST API that is deployed. In this case, it will be Postman and the terminal. ACE itself will be a bar file that's deployed, and what that does is continuously increases the utilization of the CPU so that we can force the total number of pods to increase with the horizontal pod autoscaler and then reduce back down. So this will work by the horizontal pod autoscaler watching the scale app. We then have Postman making calls to that application or the curl on the command line. And as the utilization increases because of the Java code within the app, we'll see the horizontal pod autoscaler realize that the limit has been met, and then it will spin up a new pod to deal with that increased load. Once the traffic stops hitting the ACE, we'll see the reduction in the amount of utilization. And when that utilization reduces, the horizontal pod autoscaler will see that, and it will slowly reduce the replicas down to the defined state, in this case, 1. In this demo, we already have our OpenShift cluster deployed. We also have an ACE dashboard deployed, called ACE dashboard, in the CP4I project namespace. We've deployed the application we discussed earlier, which is the Scale app, and we can see that the blocking service is there. When we click on there, we can see the address, and that's the address that we'll be calling in order to demonstrate how the horizontal pod autoscaling works. In OpenShift, we have a horizontal pod autoscaler already deployed, in this case autoscale example, and that hits the scale target. We also have a number of deployments. So we have the ACE dashboard deployed, which is this ACE dashboard, and we have the Scale app. Now, when we run the call to the app via Postman, we'll be able to see that there is traffic starts to hit this application. So we can also call it from within our terminal by running the same command. So we can run it in there again and in here again. What we can see is that our total number of core utilization has increased, so we've gone up to 0.047. As we can see, that CPU utilization is starting to increase. Run this again. We'll slowly see an increase in the number of deployments. So as we can now see, there are 2 scale applications running, and that's because it started to realize that there is a high amount of utilization against the container. Because we've run it from multiple locations, it's increasing the number of pods that are able to service the request. So you can see the CPU utilization is slowly increasing. And we can also look at the horizontal pod autoscaler, which will give us information such as that the HPA was able to successfully calculate a replica count. So we can see there's currently 2 replicas and the desired replicas are 2. There's a minimum replica of 1 and a maximum of 10. We'll just go back to the pods. Go to Scale app. We can see that they're both running. So there have been some increase of the CPU or the core utilization here. And we're about to see that slowly start reducing as time goes on. Again, we can see that there has now been a reduction in the amount of traffic coming of the CPU utilisation, and as such the Horizontal Pod Autoscaler will calculate that there's no longer a need for the additional pod. So again, if we go to the scale app, we can see that has gone down from 0.038 to 0.037, and this core has gone down to 0.211. We can see in here too a relatively low core utilisation. If we look back at the scale apps, we can see they're really starting to reduce now in the total size of the core utilisation. So the two containers are about equal in core size now. What we can also see is that they share an owner. And a quick note on the ready 1 out of 1, that means that there is one container inside the pod. And it's the pods that are scaled up, not the containers. So you still have a different pod deployed. So now that the core is reduced, we see the termination of the secondary pod that was scaled up, and that is now terminating so that we end up with just a single scale app available again. So in this demo, we've seen that a deployed ACE application has increased its core utilization. The Horizontal Pod Scaler has seen that the core utilization has increased, predicted a maximum height, and known that it needs to increase the number of pods available. It has created that pod and then scaled it back down as the core utilization has decreased.